Today's lesson is over Pythagorean Theorem. We've had Pythagorean Theorem at the beginning of the year when we worked with the distance formula, and in the last unit we used Pythagorean Theorem as well. So Pythagorean Theorem uses a squared plus b squared equals c squared to find the missing sides of a right triangle. So here I have a right triangle, and we need to identify the sides. So what we have is we have the right angle here. That indicates our right angle. And directly across from that, that is called the hypotenuse of the triangle. The hypotenuse is the longest side. And it is always directly across from the right angle. Okay, we also identify that as side C in the formula. The other two sides, that's going to be A and B, and we call those legs. So leg A and leg B, and those are adjacent to the right angle. In our first example, we want to go ahead and identify those sides so we can find the missing side. So here's my right angle, so directly across from it, that's going to be my hypotenuse, which makes the other two sides the leg. So when I use my formula, I'm going to have a squared plus b squared equals c squared. And I know one leg is 3, so that's going to be 3 squared. The other leg is 9 for 9 squared. And then I'm replacing c with x for x squared. From here, order of operations kicks in. We've got to do the exponents first. So 3 squared is 9. 9 squared is 81. And that equals x squared. Next, I would have to add. So I get 90 is equal to x squared. And then to get the square gone, I have to do the opposite, which is to square root. So I get the square root of 90 is equal to x. Now, one of the skills you're going to have to be able to perform is to simplify the radical into its simplest form. And you were taught that last year in Algebra 1. So you take your square root, and we always divide by the smallest prime number, which is 2. So 2 goes into 90 45 times. I want to check and see if that goes in again, and 2 does not. You always want to divide out the number until you can't divide it out anymore. My next prime number is 3, and 3 does go into 45 15 times. And then I check and see if I can divide by 3 again, and I can, and I get 5. Now I can't divide by 3 anymore, so my next prime number is 5. And then I get 1. That's how I know I'm done, is when I reach 1. Okay, so if you'll remember, the square root of a number is really that number to the half power, which means I need 2 of them to come outside of the radical. So I want to look for pairs of numbers, and I want to circle my pairs, because when I have 2, 2 halves make a whole. So this 3 will come on the outside of the radical. 2 doesn't have a pair, so it stays inside. 5 doesn't have a pair, and it stays inside. And those will get multiplied back together. So 3 square root of 10 is my simplified answer for x. Okay, the next section we're going to cover is the Pythagorean Converse. So we're going to use the Pythagorean Theorem. A squared plus b squared equals c squared. We know that works with a right triangle, but we can also tell whether or not our triangles are acute or obtuse as well. If a squared plus b squared is greater than c squared, then we have an acute triangle. If a squared plus b squared is less than c squared, then we have an obtuse triangle. So if we take a look at our example 2 with sides 7, 10, and 12, I want to be able to check and see what type of triangle it is. So first thing I want to do is I want to label my C side, my hypotenuse. And we know from the previous part that's got to be the longest side. So my C part is going to be 12, and I need to label that. That means the other two parts are going to be A and B. Because when I plug that in to A squared plus B squared, and I'm going to put a question mark because I've got to compare it to C squared. Well, I have 7 squared for A, 10 squared for B, and I'm going to compare that to 12 squared for C. 7 squared is 49, 10 squared is 100, and that's going to compare to 144. And I get 149, and that's going to be greater than 144. Since it's greater than 144, this is going to be an acute triangle. An acute triangle. Okay, the next section we're going to go over is the Pythagorean triples. And those are positive integers that fit a squared plus b squared equals c squared. And there are few that are used quite often. So the first one is 3, 4, and 5. 5, 12, and 13. 6, 8, and 10. 7, 24, 25. And 8, 15, 17. Now, you will see these on any standardized test. That means the PSAT, SAT, ACT. I've seen it on the GRE, and I've seen it in other tests in the medical field. So, it would be very beneficial for you to memorize these 5 sets of numbers because they are used very often. In fact, on your last worksheet, all of these except the 7, 24, 25 was used. Okay, now what's unique about these is that they can be multiplied or divided for more triples. Okay, so these aren't the only ones. This is like your base set. So what that means, if I take 6, 8, 10 here, that's really the 3, 4, 5 multiplied by 2 to get 6, 8, 10. Okay, so I can double and triple and half these any way I want, and I can form more triples. Okay, let's look at an example. So I have a triangle here that is 4, 5, and x. I want to identify the parts of the triangle. X is directly across the right angle, so that makes it my hypotenuse. That makes 4 a leg, and that makes 5 a leg. So what I want to know is this triangle a Pythagorean triple? Well, I see 4 and 5. And I remember that I had 3, 4, and 5 as a triple. But I also know that the hypotenuse should be the longest side, which means 5 should be here instead of x. So I'm not sure if it's a triple yet. So we're going to have to do the Pythagorean theorem, a squared plus b squared equals c squared, to see. We already identified my legs, so 4 goes in for one of the legs, 5 goes into the other, and it doesn't matter the order. I could have 5 and then 4. And then I'm going to square my numbers. 16 plus 25 equals x squared, and then I'm going to add them. 41 equals x squared, and then I've got a square root because I got to get rid of the square. So I'm going to square root both sides, and I get the square root of 41 is equal to x. Since we're practicing simplified radical terms, I need to see if I can simplify this, and I can't, and the reason that I can't is because 41 is a prime number. Okay, so since my side is a radical, is this triangle a Pythagorean triple? No. C is a radical side. Okay, so no, it is not a Pythagorean triple because a Pythagorean triple has to have positive integers. Okay, let's move on to example 4. This is a multi-step problem. I have more than one right triangle here. I mean, I have my triangle, the big triangle, but I see a right angle symbol. So that means that this smaller triangle on the right is a right triangle, and this triangle on the left is a right triangle. Okay, I don't know the length of this bottom side, but I do see that I have 9 and 15. And when I see that, I recognize it as a triple. Okay, so how do I know it's a triple? Well, I see 9, I'm missing a side, and I know 15 has to go on the end because it's the hypotenuse. And what I'm going to do is I see that 9 and 15, they could be divided by 3. So if I divide everything by 3, I get 3 blank and then 5. Ooh, well, I remember I had a triple that was 3, 4, 5. So the missing side is 4. Since I had to divide it by 3 to get 4, that means I have to do the opposite to get my missing number, which is to multiply by 4. So my missing side is 12. So 12 is going to go here. Now, because my entire length is 25, and I just found part of it is 12, that means the other part is 13. That helps find my other leg in the second triangle. So now I have both legs here. I have 9 and 13. I don't recognize that one as a triple, so I'm going to do a squared plus b squared equals c squared. And I'm going to use 9 squared plus 13 squared, since those are my legs, and x represents my hypotenuse because it's across from the right angle. Square my numbers. 9 squared is 81. 13 squared is 169, and that gives me x squared. Add them together. I get 250 is equal to x squared. And then I need to square root. 250, square root of 250, square root of x squared. And I get the square root of 250 is equal to x. I do need to simplify, so I'm going to come over here and take 250, and like I said, we always start with our smallest prime number, 2. 2 goes into 250 125 times. I check 3, and I use the divisibility rule on 3. I add the digits, 1 plus 2 plus 5, and I get 8. 8 is not divisible by 3, so I can't divide this number by 3. My next prime number is 5, and I know I can divide by 5 because of the divisibility rule, it ends in 5. And I get 25. I can divide by 5 again because I want to divide out all the 5s that I can, and I get 5. I can divide by 5 again, and then I get 1. That's how I know I'm done, is when I reach 1. Now I want to circle all of my pair of numbers. Remember, it takes 2 to make a whole. So I have a pair of 5s. 5 is going to get to come outside of the radical. 2 doesn't have a partner, so it has to stay inside. 5 doesn't have a partner, it has to stay inside, and I multiply them back together. So I get 5 square root of 10 is my simplified answer. Okay, so now you're going to practice on your own.